I minimize it, and then I just start talking or do whatever I need to do, and the computer will actually record what I'm saying. Because I'm talking to the whole class, right, I'm talking a little bit loud, the microphone's right in front of me, so when it comes out, the video, you might have to turn down the volume when you actually watch it later on YouTube. But this was your homework. We're only going to go over a couple of the problems on here because some of them we did in class. I think we did 1 through 3, or we at least discussed 1 through 3. So we're going to go ahead and try numbers 4 and 5. And from there, we're going to move on and go over the review sheet that you have in front of you. And we'll go over each individual problem on that review sheet. And then you should be good to go for, whatever you have to do. So let's see here. Let's go ahead and take a look at this first problem. So when I take a picture of that, it brings it into this other program where I can actually do stuff with it. So we're going to go ahead and identify the stuff that was in, oh wait, we're not starting on number 1, right? I said we're starting on number 4. So let's go ahead and come over here and do number 4. Oh, don't want that. Okay, so for this problem right here, what kind of information was given to us in this problem? So the acceleration is right here. What else? So this is our final velocity. What else? So one more thing. This rest part tells us that our initial velocity was equal to 0 meters per second. Okay? So this is the stuff that was given to us. What are they asking us to find? How long will it take? So it's the time, right? So they're asking you to find the time. So the equation that we would use that incorporates all 4 of these, and by the way, you will have the equations available to you tomorrow to use on the test. You just have to pick the right one here. So the equation that you could use to solve this would be VF minus VI equals what? Acceleration times time, right? We can plug this stuff in, and our final velocity would be 28 meters per second. Yes. 28 meters per second, and we're going to subtract the initial velocity of 0. And that equals our acceleration of 2.3 meters per second squared times the time. So I'll put that in parentheses. You can see that it's multiplying. Okay, so when I simplify this, 28 minus 0 is 28, right? And then 2.3 times t will bring that down. What do I do to get the time by itself here? Divide both sides by the 2.3. Well, we divide by 2.3 here instead of 28 because we want to get rid of this to make t by itself, right? So it'll be t equals something. Okay, so here we'll end up with 28 divided by 2.3. You all have calculators, so someone spit that number out for me, please. So 12.2 seconds would be our time for this car. Does anybody have any problems with this problem right here? There's going to be one that's very similar to this on the test, so you could have used a different formula and got the same answer. That's correct. Yeah, I mean, in this case, you could have actually used 2 other formulas that are on that sheet, right? Yeah, exactly. It's not with all of them. It's just certain problems you can use different equations, but they're not all going to be like that. For most of them, there'll only be one equation where you can actually use all the numbers and get the right answer. For most of the equations, it'll be like missing 2 things that you need, so you can't use it. Okay. All right, so let's go ahead and look at number 5 here. All right, so it says the skateboard is moving at a constant velocity of 1.75 meters per second. This is the acceleration, right? And they want to know how much time will pass before she begins to slow down and move backwards, before she starts moving backwards on the incline. Sometimes it helps to draw a picture, so we can go ahead and draw a picture here. So this little ramp here that she's going up. So we've got this girl, and she's going up this ramp, and we want to know the time it takes before she gets to a point where she starts rolling backwards, right? So we want to know the change in time. The initial velocity here was 1.75 meters per second. The final velocity that we're going to be using is what? 0, right? Because they want to know the time it takes for her to get to a point where she starts rolling backwards. Well, the last point would be that we're looking at would be where she's at 0. So at the very top of this motion, she's at 0 meters per second. And the acceleration for the problem was negative 0.20. Right, so we're going to use that equation that we just used. It'll be VF minus VI equals AT. So it'll be 0 minus 1.75 meters per second is equal to negative 0.20 meters per second squared, the acceleration, times the time. So it's not a plus sign, that's a T. All right, that's why I do this little curly thing at the end. That way y'all don't confuse it. So right here, 0 minus 1.75 is negative 1.75. And then we've got negative 0.2 times T. So what do I do to get the T by itself? Divide both sides by that negative 0.2, right? Make sure you put the negative in there. And we should get a time equal to what? Time will equal this divided by that. So negative 1.75 divided by negative 2 is what? Negative 0.2, sorry. 8 point what? So we'll just go ahead and say 8.8 seconds. So she's going to go 8.8 seconds up this ramp before she starts rolling back. Anybody have any questions about this one? No? I guess obviously the tricky thing here is that in this case they're showing you, they're not telling you that the final speed is 0. You just have to read the problem and interpret, oh, well, the last point would be 0 right before she stops. There are other problems like this, right? What if you threw a ball up in the air? Well, the very last point before it started coming down would be 0 speed, right? If I went ahead and shot you up in there with a cannon, for a split second at the very top, you'd be stopped, right? You'd be motionless, and then you would immediately start falling down, right? Okay. So let's see here. Those are the only two that I wanted to go over from the homework because those are the two that really represent the kind of problems you would see. Looking at your review, though, we do want to go over some of this stuff. So go ahead and take a look at your review for me. We'll go ahead and take a look at this first one. All right, so for the following velocity versus time graph, calculate the acceleration or the slope. So for this case, it would be, you're going to have some time to finish the homework, so don't worry about it right now. It would be rise over run. Remember, slope is equal to rise over run. So in this case, if I was trying to find the slope of this graph, what would be some convenient points to pick to find the rise over run? Does everybody agree with him? You want to do 0 and 2? So by 0 and 2, you're talking about the time, I guess, right? So we're going to go ahead and start at 0, and then we'll pick a point at 2. Those look like good points there for us to use. So if we're doing rise over run, the rise here would be right there. And how much is that? 10 meters per second. And then the run, 3 seconds. So in this case, we'll go ahead and put that in there. And in this case, that's going to equal our acceleration. And you see how it's meters per second over seconds, right? And that's how you end up with units of meters per second squared, because you have seconds divided by seconds times seconds right here. So it's seconds times seconds, yeah. It's m over s, so really this s is down here, but it's just the way we wrote it. Yeah, it would be 5 meters per second squared. So 10 divided by 2. And this is different. Remember, this is a velocity versus time graph. Velocity versus time, I can tell because of the units. Make sure you pay attention to that on the test. Because if they give you a position versus time graph, then when you get the slope, it's not acceleration, right? What are you getting for a position versus time graph? We talked about this yesterday. On a position versus time graph, when you get the slope, you're actually getting the velocity, right? So make sure that you don't confuse those two, because that's something that people confuse a lot. Okay, so that's the first thing on the review that you need to know how to do for the test. Tomorrow. Yep. Let me go ahead and zoom this down to 75 so you can fit it all on here. Alright, so looking at this one. Alright, now this is a little bit different than what we did with the position versus time graphs. So for segment A to B, what's happening for this object? Okay, so I'm hearing increasing speed. If we look at this, this is a velocity versus time graph. So it's not a position time graph. So don't get confused with what that slope means. Remember, and the slope of a velocity versus time graph, that shows you accelerations, right? So what's happening to the speed of this person? Well, if this is 0, well then let's say this is like -2 over here, right? So if it's at -2 and it's going to 0, what's happening to its speed? If you go from -2 to 0, you're getting faster. Remember, negative velocities just mean backwards, right? Direction. So if it's getting closer to 0, that means it's slowing down. Because you had a certain speed, 2 meters per second. Yeah, it's negative, but that just means you're going backwards. Okay. So here it's 2 meters per second. You're going backwards, but you still have a speed. But here at B, you don't have a speed. You're at 0 speed. So you had to have slowed down, right? So this is a person who is going backwards and slowing down. Okay, so that being said, what about B to C? It's going faster. I know that because it starts at 0, and now it's at some other speed that's greater than 0, right? So from B to C, I know it's going faster. What direction is it going? Forward, because it's positive velocities, right? These are all positive numbers. They're above 0. So this is going to be forward, and it's going to be getting faster or accelerating. What's that? It's not constant because you see how the speed is getting faster every time? That's a position versus time graph. On a position versus time graph, if it's a straight line, anywhere it's constant. That's right. But this is a velocity versus time graph. And I don't want you to confuse the two on the test. All right, what about C to D here? Okay, so it's slowing down, so it's decreasing speed. Which direction is it going? Anything that's positive velocities means forward. So anything that's above 0 is going to be forward. So this is forward. Because you're confusing the position time graph and the velocity time graph. On a position versus time graph, going down would be backwards, right? But because we're looking at velocities now, remember on a position time graph, I said anything with a positive slope is a positive velocity. You're going away, right? Okay, now in this case, though, this is still a positive velocity. It's like, let's say this is 1 meter per second. It's positive 1 meters per second. So all that's happening is the person is walking this direction, but they're slowing down. Yeah, once they get into the negative speeds, negative velocities down here, then it's going backwards. So if, like, let's say here at G, he had gone down like this over, well, all this stuff would be going backwards. Okay? Yeah, at a fast acceleration and then staying at the same speed. Yeah, so number DE or DE here is going to be Staying the same speed, so this is a constant speed, but which direction? So this is going to be forward, and it's going to be constant speed. What about EF? Well, in EF, you've got positive velocity still, right? But it's coming to 0. So it's going to be still forward because they're positive speeds. And it's going to be decreasing speed, right? So slowing down. And then the last one, FG, is what? It's a constant speed of what? Which means what about the person? They're stopped. They're stopped where they're at. They're stopped. Not slopped. Stopped. All right, are there any questions about that one? I know that one's kind of confusing with the position time graphs. Make sure you don't confuse the two. That's very important, all right? No, but you can study tonight and then you can watch this video like 5 times at home on YouTube, at least. Yeah, what I'm recording right now is all going to be on there just like I'm saying it. What's that? I'm just doubling it up, so if you want to go back and watch it again, you can. All right, now on this one, let's go ahead and start here, though. The velocity of an object is equal to its distance over time, right? So if I wanted to know the displacement of something, what would I do with the velocity and time? Well, I'd multiply both sides by t, and then this would cancel, and you end up with distance equals velocity times time, right? Is everybody okay with that? Okay, so at this point, if I know distance equals velocity by time, take a look at this graph. This is a velocity versus time graph. If I wanted to go ahead and find that displacement on this graph, what I'm going to end up doing, go ahead and sketch this out real quick so you can see it. So this part right here, I've highlighted this rectangle. If I was to get the area of this rectangle, you know, area of a rectangle is what formula? Length times width, right? So length times width. So the length times width of this rectangle would be what? 6 to 14 is a distance of what? 8. So we've got 8 times the length, which is what? 16. What are these really? Well, this is 8 seconds. So I'll put in seconds right there. And this is 16 meters per second. Well, look at that. This is a velocity. This is a time. I'm multiplying them, right? So I'm actually getting the distance. So when I get the area underneath the curve, when I say curve, underneath the line here, of a velocity versus time graph, I'm actually getting the displacement. So 8 times 16 is what? What is it? 128 meters. And then over here, how would I get the area of this triangle right here? 1/2 base times height. So the base is 6, and the height is 16 again. So 6 times 1/2 is 3. 3 times 16 is what? 48. 16 times 3 is 30, and then 48. 40. Somebody use your calculator. 3 times 16. 48. All right. All right, and then what about this area right here, this trapezoid? What would y'all do for this? Well, you can split it right here, and then you've got a rectangle and a triangle. So 21 and 14 is a difference of 7, right? So this one will be 7 times the height of 11 is 77 meters for that part right here. And then what about this triangle up here? The base is 7 again, so it's 1/2 times 7 times a height of 1, 2, 3, 4, 5. So 7 times a half is 3.5. 3.5 times 15 is 3.5 times 15, times 5, sorry. Right. 17.5 meters. So to find the area or the distance, you just add all this up. So it'll be 128 plus 48 plus 77 plus 17.5, and that gives us a displacement of what? (270.5 meters). All right, good job. So this is how you would get the distance on a velocity versus time graph. You just calculate all this area underneath. All right, now looking at the problems here, we're going to do the first 4. This last one I decided not going to give you on the test. All right, now this one right here. Oh no, what is that all about? Oh, I see what it did. No. All right, so this says you throw a frisbee for a distance of 65 meters to capture the woman's record. If the frisbee was thrown horizontally at 3, how long did the frisbee remain aloft? So we'll go through this just like we did the other ones. This is our what? 65 meters. Our displacement, our distance. If the frisbee was thrown horizontally at 3 meters per second, that'll be our velocity. And then how long is going to be time, right? We're looking for time. Yes, the equation here is V equals D over T. So we'll go ahead and substitute in the distance and the time. The distance and the velocity, sorry. So it'll be 3 meters per second is equal to the distance of 65 meters divided by our time that we're looking for. For algebra, what would we do to solve this? Oh, you're close. Right now, t is on the bottom, right? So we actually multiply both sides by t. And you would get 3t is equal to 65. Then what do we do to get t by itself? Divide both sides by 3. So the time in this case is going to be 65 divided by 3, which is what? So 21.7 seconds would be our time for the frisbee. This is one of the more basic problems, and this is very similar to a problem that you'll see on the test. So as long as you're able to solve it, you'll be in good shape. All right, so taking a look at number 2 here, the second one. A little too fast? But I'm recording it so you can go back and play it in slow motion. Yeah, I'm recording it right now. All right, so right here it says a car traveling at an average speed of 10 meters per second is in a time of 2 hours 5 minutes. How many kilometers did the two travel? So the 10 meters per second is your what? Speed. And this is your 2 hours 5 minutes is what? Time. And they want to know how many kilometers. Kilometers is a distance, right? So you're looking for distance in this one. The equation will be the one that we've been using. Velocity equals distance over time. We'll substitute in our numbers. So the velocity here is going to be the 10 meters per second. Our distance is what we're looking for. And our time, are we going to put 2 hours 5 minutes under here? No, we want to convert that into seconds, right? So in 5 minutes, well, seconds because our velocity is in seconds, right? So right here, 2 hours, 5 minutes. How can we convert this into seconds? Well, first, how many minutes are in 2 hours? 120, right? 60 times 2 is 120. So we have a total of 125 minutes here. And we'll multiply that by 60 because there are 60 seconds in a minute. So this times this gives you a total of seconds. So we'll go ahead and put that time down here instead of, let me go ahead and erase that. So you multiply both sides by the time, 7,500. So you end up with distance equals 75,000 meters. If this is in meters, though, they want the answer in kilometers. So what would I do with that? How many meters are in a kilometer? 1,000, right? So we would actually divide this by 1,000 to get our distance in kilometers, which is 75 kilometers. So the car traveled 75 kilometers for this problem. Everybody okay with that? Better be. Sure. Okay, well in this case, D is on the top, right? And we want it by itself. Right now it's being divided by this. So you multiply both sides by 7,500 because the 7,500 will cancel. Well, what happens is when you multiply by 7,500, this ends up being 7,500D over 7,500, right? Because this times this is over that, and then they cancel. So that's what I was doing there. Okay? You're not stupid. All right. Capture number 3. No, keep doing that. All right, so for this one right here, it says you've got a car that's going 10 meters per second. This is an acceleration, right? And then they go this speed, and they want to know how long, so they're talking about a time. What do these numbers stand for? What is the 10? Oh, close. It's meters per second, right? So it has to be a velocity. So it's your initial speed. This is the acceleration, and then this is your final speed, right? Because that's the speed that you're coming to. So the equation here is going to be one that y'all are used to. VF minus VI equals AT. We'll plug in all these numbers, so it'll be 20 minus 10 equals 2 times T. 20 minus 10 is 10. And then to get the T by itself, I divide both sides by 2. And you end up with time is equal to 10 divided by 2, which is 5 seconds. Right, because we're looking for time, right? So we want to keep it in seconds. Easy. You can do that one in your sleep. All right, and then the last one that we're going to go over here. I don't know why I did that. Oh, you know what? I can undo it, I think. There you go. All right, this one's a little bit trickier, and it's probably the hardest one you'll have on the test. So this one right here. Yeah, the rocket one. All right, so on this one, what do we got here? We've got rest, 45 meters per second squared, and then 700 meters. So what does this stuff stand for up here? Right, this is the initial velocity, it's 0. What about this? That's your acceleration. And what about this? Distance. In this case, instead of saying distance, I'm going to call this the final position. Remember this from the formulas, right? This is the final position of this rocket. Okay, the initial position of this rocket was probably what? We always start at 0 when we're measuring, right? So the initial position of this rocket was 0. And we've got this. I think we're ready to go. So let's go ahead and use our equation. Based off of the homework equations that are available to you right now, which equation do you think we should use? And what is the fourth one? Equals xi plus this is the right one, that's right. And the reason this is the right one is because even though t is on there twice, what ends up happening is if we plug all this stuff in, we actually get 700 meters equals 0 meters plus 0 speed, right? Times t plus 1/2 times 45, right? Because I'm getting the 45 from there. Times t squared. Now, to simplify this, anything plus 0 is what? It's the same, not 0. It's the same thing, all right? And then anything times 0 is 0, so we don't have to worry about this either because these don't make any impact on it. So right here we have 1/2 45 t squared equals 700. That's much easier to do. 1/2 times 45 is 22.5, right? What's the next step algebraically from this step? Not the square. Divide both sides by 22.5. Good. So these cancel, and you end up with t squared equals 700 divided by 22.5, which is what? What are these two divided by? 700 divided by 22.5. So 31.1, and then how do we get rid of this square up here? Square root what? Square root both sides, right? All right, so t equals square root of 31.1, and what is the square root of 31.1? 5.5 seconds would be the time it took for this rocket to go 700 meters, which is extremely fast for the rocket. Does anybody have any issues with this problem right here? Well, I can tell you for sure that the 4 problems on the test, the calculation ones at least, are very much like these. Very much like these. So if you study them, you'll do really well on that. And then the multiple choice questions on the test are going to be very similar to all the graphing stuff that we talked about. Yeah. All right, so if you do have any issues, though, I encourage you to go ahead and look at the recording. As you can see right here, it's 33 minutes, 3 minutes.